Today we are going to discuss implicit differentiation. So far, all of the equations you know how to derive have been in explicit form, meaning they're solved for y. Y equals 3x squared minus 5, y equals sine of x, y equals whatever equation we've dealt with. Implicit form implies the function is not solved for a specific variable. So notice that these are not solved for y. They're mixed together. Some of them we could solve for y. This one we could solve for y and maybe do the derivative. This one we could solve for y, but we'd get a plus or minus, which we don't know how to derive. Same with this third one. So instead, we're going to derive implicitly. When we derive implicitly, we differentiate both sides with respect to x. What that means is x's derivative is 1, but every other variable has a derivative. So when we derive a y, it derives to a 1, but then you have to multiply by the derivative of y, which is dy dx. Then, collect all terms. Step 2, collect all terms involving dy dx on the left side and move all other to the right side. Thirdly, factor dy dx out of the left side. Fourth, solve for dy dx by dividing both sides of the equation by the left-hand factor that does not contain the dy dx. So, let's try it. Differentiating with respect to y, remember that y has a derivative, x's derivative is 1. So, when we derive a term with just an x, like an x squared, it derives like normal. Derivative of x squared is 2x. Derivative of y squared we derive as if it were an x, so 2y, but it's not an x, so we have to multiply by the derivative of y. And the derivative of 16 is 0. So, now we can collect our terms that have the dy dx on one side, move everything else to the other side, so I moved my 2x to the right, divide by the part that doesn't have the dy dx, and we find out that dy dx equals negative x over y when reduced. Now, sometimes they get a little bit harder. We're going to do multiple steps with A. We're going to find dy dx, we're going to find the equation of the tangent line, and we're going to find what values of x is the line horizontal. So first of all, find dy dx. So derivative of 3x is 3x squared. Derivative of y cubed is 3y squared times y's derivative equals, here we're going to need the product rule. The derivative of is 6x. The derivative of y is 1 times dy dx plus the second derivative of 6x is 6. So, now, keep our 3y squared dy dx on this side. Move our 6x dy dx to the left. And at the right, we have 6y minus 3x squared. I apologize, this should be a square. Now, pull out our dy dx. We're left with 3y squared minus 6x equals 6y minus 3x squared. Divide. Dy dx is equal to 6y minus 3x squared divided by 3y squared minus 6x. And we're almost done. We can reduce everything by 3. To get 2y minus x squared over y squared minus 2x. Now, for part B, it says find the equation of the tangent line at 3, 3. We need slope. Slope equals the derivative with the point plugged in. Now, in the past, we've only had to plug in an x because our derivative only had an x in it. Now that our derivative has an x and a y, we're going to need both. So, y is 3, x is 3. This is all coming from this derivative. Over 3 squared minus 2 times 3. We end up with 6 minus 9, so a negative 3 at the top, and at the bottom 9 minus 6, 3, or a slope of negative 1. So the equation of our line, y minus 3 equals negative 1 times x minus 3. Y equals negative x plus 6 when we simplify. Now part C is a little bit interesting. Part C says for what values of x is the tangent line horizontal? For a tangent line to be horizontal, that means the derivative, which is 2y minus x squared over y squared minus 2x, has to equal 0. When a fraction equals 0, what part of the fraction has to equal 0? It's not the bottom. We're not allowed to divide by 0. It's the top. 2y minus x squared equals 0. Now, we're trying to solve for x. We can't solve for x if we also have a y in our equation. So, what should we do? Well, we solve this for y. We get x squared over 2. And we could do a system if we had another equation involving the same x and y. We've already used the derivative, so what we're going to do is climb up here to the top, and we're going to use our original. And everywhere there's a y, we're going to plug in this x squared over 2. So x cubed plus x squared over 2 cubed equals 6 times x squared over 2. And we need to solve this equation for x. So, x cubed plus x to the 6th over 8 equals 3x cubed, because our 6 and our 2 will reduce. I'm going to subtract x cubed. X to the 6th over 8 equals 2x cubed. I can multiply by 8. X cubed equals 16, x to the 6th, equals 16x cubed. Divide by x cubed. X cubed then equals 16. And we end up with x equaling the cube root of 16. Also, when we divided by this x cubed, that gave us one other solution, and that is x equals 0. When some of your factors of x disappear, you have to consider them a solution. So x equals 0 is also a solution. Your other option here would have been to take the x to the 6th minus 16x cubed equal to 0, and then you're going to find this x cubed, so x will be 0, and from here x will be the cube root of 16. So either option is fine. Second one, you're less likely to lose things rather than divide x's away. Let's try another one. xy. So let's rewrite this. The square root of xy would be xy to the 1/2 equals 1 plus x squared y. It's not solved for y. You're not going to be able to solve it for y, so we are going to derive implicitly. Keep that in mind. When you're given implicit equations to derive, they're not going to tell you they're implicit. You need to know you need to use implicit differentiation because it's not solved for y. So, the left side is going to need the chain rule. Derivative of something to the 1/2 is 1/2. That same thing to the negative 1/2. Well, that thing is xy. But now we need xy's derivative. X times y means we need the product rule. So we do the first times the derivative of the second plus the second times the derivative of the first. On the right side, the derivative of the 1 is 0, so we don't have to worry about it, but the derivative of x squared y is also going to be a product rule. X squared times the derivative of y plus y times the derivative of x squared. Now, this algebra is going to get a little bit tricky. I'm going to write this as 2 radical xy. And this next term can actually go in the numerator, x dy dx plus y equals x squared dy dx plus 2xy. I'm going to multiply both sides by 2 radical xy. I've got x dy dx plus y equals 2x squared radical xy dy dx plus 4xy radical xy. Now we need to solve for dy dx. Keep our x dy dx on the left. Move the 2x squared radical xy dy dx to the left. Keep the 4xy radical xy on the right, and bring the y to the right also. Pull out your dy dx, and we have x minus 2x squared radical xy equals 4xy radical xy minus y, and dy dx is equal to 4xy radical xy minus y divided by x minus 2x squared radical xy. And there isn't anything you can pull out of each that will cancel. You can take a y out of the top, but you can't out of the bottom. And you can take an x squared out of the denominator, but it's not going to cancel with, take an x out, but you can't cancel with anything in the top. So that is our final answer. Next one's a little weird. It says if g of x plus x sine of g of x equals x squared, and g of 1 equals 0, find g prime of 1. To do this, we're going to have to derive. So, derivative of g of x is g prime of x. Derivative of x sine g of x is going to be the product rule. Keep your x. The derivative of sine of g of x is going to be the quotient rule. It's cosine of g of x times g prime of x plus sine of g of x, keep the second, times the derivative of x, which is 1, equals 2x. So, at this point, they wanted us to find g prime of 1, so I'm going to plug 1 in for all of my x's. G prime of 1 plus 1 cosine of g of 1 plus times g prime of 1 plus sine of g of 1 equals 2 times 1. So we end up with g prime of 1 plus cosine of 0. G of 1 is equal to 0. So cosine of 0 is 1 times g prime of 1 plus sine of 0 is 0 equals 2. So we combine like terms. 2g primes of 1 equal to 2. So g prime of 1 is equal to 1. And we're finished. For this next example, derive this in terms of y, meaning y's derivative is 1, but anytime you derive an x, you get a dx dy. Give that a try, and we will talk about it